video, we will be looking at 8F, using tree diagrams. So tree diagrams are very useful and visual ways that we can represent different probabilities. Tree diagrams can be used to list the sample space for experiments involving 2 or more stages. Branch probabilities are used to describe the chance of each outcome at each step. Each outcome for the experiment is obtained by multiplying the branch probabilities. So this is quite important. We multiply the branch probabilities to get each outcome. Branch probabilities will depend on whether selection is made with or without replacement. So let's have a go at trying to use tree diagrams. Boxes A and B contain 5 counters each. Box A contains 3 red and 2 green counters. Box B contains 1 red and 4 green counters. A box is chosen at random and then a single counter is selected. A is asking us if box A is chosen, what is the probability that a red counter is chosen from it? We are looking for a red counter from box A. You can see in the question that box A contains 5 counters in total. So that tells us that the probability of obtaining a red counter from A is going to equal to 3 over 5, because there are 3 red counters and a total of 5 in box A. In part B, if box B is chosen, find the probability that a red counter is chosen from it. You're looking for the probability of a red counter. That means we're looking at this number here, 1 red, from a total of 5 counters. So once again, the probability will be 1 over 5. In part C, represent the options available as a tree diagram that shows all possible outcomes and related probabilities. So to draw this tree diagram, we know that there are going to be 2 boxes, box A and box B. It says in the question, you can only get red or green counters. So assuming that the probability to obtain box A or B is going to be equal, that means to get to box A or B, this must equal to half. Okay, so from box A, we know there are only red counters and there are only green counters. The same can be said for box B. So 1 red, 1 green. We also worked out from part A that the probability of obtaining a red from box A will be 3 over 5. So that means the probability of green must be 2 over 5. From part B, we figured out the probability to get a red from B is going to be 1 over 5. So that means the probability of green must be 4 over 5. So now we have to have the outcomes. If we follow the branch, we're going from A to red. The first outcome is going to be A in red. Second outcome will be A in green. Third outcome will be B and red. And the last outcome will be B and green. Now finally, we need to have a probabilities column. To get this, we just need to multiply across. So the probabilities to get the outcome of A in red will be half multiplied by 3 on 5. Remember our rules? We need to multiply the branches across. So A in red is going to give me 3 over 10. The probabilities to get A in green will be half multiplied by 2 on 5, which will give me 1 on 5, simplified. The probabilities to get B in red will give me half multiplied by 1 over 5, which will give me an answer of 1 over 10. And finally, to get the probability of B in green, this will be half multiplied by 4 on 5, which will give me an answer of 2 on 5, simplified. In part D, this is asking us what is the probability of selecting box B and a red counter. So probability of box B and a red counter. So let's just go B red. So if you follow our table, or should I say our branches, we worked out B in red is this combination here. That's going to be half times 1 over 5, which will give me 1 over 10. Part E is going to ask us what is the probability of selecting a red counter. So in this case, it's going to be red. If we look at our outcomes tree, we can get red from here. That's A in red. We can get it up from here as well, which is B in red. That's going to be 3 on 10 plus 1 on 10. That will give me 4 on 10, simplified. Okay, let's move on to the next one. A bag contains 4 blue, 5 white marbles, and 2 marbles are selected without replacement. So we've got 4 blue, 5 white, 2 are selected without replacement. Part A, draw a tree diagram showing all outcomes and possibilities. So the first step for this one is to ask yourself, how many marbles do we have in total? It will be 4 plus 5, which gives us a total of 9 marbles. So keep that in mind. So there's only 2 colors that we need to worry about. It's going to be blue and white. The probability of picking a blue initially is going to be 4 on 9, which means the probability to pick a white will be 5 on 9. So the probability to also choose another blue, because it's without replacement, our total gets smaller every time we choose. So instead of becoming 4 on 9, it will now become 3 on 8. So that means the probability of picking a white must be 5 on 8. One important thing to notice how the branches add up to 1 every time. Okay, so it will never add up to more than 1. Okay, and it shouldn't equal less than 1 either. If we pick a white the first time, the probability is 5 on 9. The probability of getting to a blue from a white without replacement will be 4 on 8. Which means the probability of getting a white after a white will be also 4 on 8. Once again, the branches add up to 1. So once you have this, we want to draw our outcomes. So initially, this first outcome will be B and B, so blue and blue. This one will be blue and white. This one will be white and blue. And this one will be white and white. Once we've drawn this, we need to have our probabilities column. To get the first one, it's going to be 4 on 9 times 3 on 8, which is going to give me an answer of 1 over 6 simplified. For blue and white, we will get a value of 4 on 9 multiplied by 5 on 8, which will give me a value of 5 on 18 simplified. For white and blue, we're going to be given 5 on 9 multiplied by 4 on 8, which will give me a value of 5 on 18 simplified. And finally, to get white and white, this will just be 5 on 9 multiplied by 4 on 8, which will give me a value of 5 on 18 simplified. Okay, part B. Find the probability of selecting a blue marble followed by a white marble. So the combination or the outcome of BW. So to get BW, it's this one here, 4 on 9 multiplied by 5 on 8, which gives us 5 on 18. Probability of blue then white is going to be 5 on 18. In part II, we're looking for the probability of 2 blue marbles. So the probability of 2 blues, well, that's going to be the first one here, which will be 4 on 9 multiplied by 3 on 8, which gives us 1 on 6. In part III, we are looking for the probability of exactly 1 blue. So there's only 2 combinations that's going to give us that. Let me get blue. We can either get white and blue, or we can get blue and white, because we only want 1 blue. So that means it's going to be 5 on 18 plus another 5 on 18, which should give me 10 on 18, or in other words, it should give me 5 on 9 simplified. And finally, in part C, this is asking me if the experiment is repeated with replacement. Find the answers to each question in part B. So for this question, we're going to need a bit more space. Let me redraw our tree diagram with replacement. So we are back. Now, to get the outcome B and B, it's going to be 4 on 9 multiplied by 4 on 9, which will give me a value of 16 on 81. To get BW, it's going to be 4 on 9 multiplied by 5 on 9, which will equal to 20 on 81. To get WB, that's going to be 5 on 9 multiplied by 4 on 9, which is going to give me 20 on 81. To get WW, that's going to be 5 on 9 multiplied by 5 on 9, which is going to give me 25 on 81. So let's look at doing those questions again, but this time with replacement. So for part A, this is going to ask us a blue marble followed by a white, so B and W, probability of B then a W. That's just going to be this one here, 20 on 81. In part II, this is going to ask us probability of 2 blue marbles. So probability of 2 blue marbles, or blue and blue, 16 on 81, according to the outcome. So that's just 16 on 81. And finally in part III, that's asking us exactly 1 blue marble. Blue and white, blue and white. So it's 20 on 81 plus 20 on 81. That's going to give me a value of 40 on 81. Okay, so that's it for this video. Hopefully you learned something. I'll see you on the next one.